Hi there. Well, this is the last video for these two chapters, and then I'll start opening up the homework assignments and you can get busy. Now, this one is 2.7, and I believe it's 2 points. Yes, it is. I've done so many of these. All right, now 2.7, the only thing we're going to do in here is we're going to combine like terms. So that'll be the only topic for this section. So when you're looking at this here, this right here is a term. 5x is a term. Negative 3y is also considered a term. And 4 is a term. Kind of looks like there's a negative there. All right. So these terms are, you've got your plus or minus. You do need to include the negative there with that term. Over here on number 6, the terms are negative 3a is a term. Negative b is a term. And again, if there's not a number in front, this is actually a negative 1b. The coefficient in front, so the coefficient here is a negative 3. The coefficient here is a negative 1. And then we also have the term 18C. So they're separated by plus or subtraction symbols, but you do need to include that subtraction as a negative. So again, the coefficient on this term is a negative 3. The coefficient on this term is a negative 1. And the coefficient on this term is 18. Let's go ahead and look here. The coefficient on this term is 5. The coefficient on this term is a negative 3. And the coefficient here, it actually has a degree of 0, but this is just a constant. Okay, we'll just call that a constant for right now. Now, if the terms match in variables, you can combine the coefficients in front, which brings us to number 7. So if you look at the instructions, because sometimes the instructions, you have to practice deciphering what they want here. So they want you to combine like terms to form an equivalent expression. Equivalent means that it has an equal value, it just will look different, but the value is the same. An expression means that you've got these terms, but there's no equal sign. As soon as you put in an equal sign, it's called an equation. But what we're doing is we're simplifying expressions. So let's look here. We have two terms, 14a and 5a. They are like terms because the variables match. Not only do the variables have to match, but also the degree or the exponent has to match too. So if they are a perfect match, a to the first, then you can combine the numbers in front, or what we call the coefficients in front. So you actually have 19a. Okay, 19a is the answer. All right, these are equivalent expressions here. If you were to put a 1 in for the a, 14 times 1 plus 5 times 1 would be the same as 19 times 1. You would get the same value. All right, let's look at number 8. Here, the like terms. Let's start with our variable. This variable matches this variable here. So those two terms are like terms because they have the same x to the first. Because of that, I can combine the numbers in front, or the coefficients in front. 24 and a negative 19. 24 and a negative 19 is a positive 5 x's. You have 5 x's. 24 minus 19 is 5. So those are done. Sometimes it's nice to cross them off, especially if we have a long list. Next, we have two constants, and you can combine the constants together. Here is a -6. You can go plus a negative if you want to, but this is a -6 and a +10. A -6 and a +10 is a +4, because those 6 negatives will take care of 6 of those positives, which leaves you with 4. You're done. You cannot go any further because this 4 does not have an x. So if they're not like, they have to stay separate from each other. So it's just 5x plus 4. There's your answer. There's your equivalent expression, or a simplified expression. I guess okay, let's do 2 more, and then we'll go on to our last section. Okay, looking at here, we need, sometimes you don't have anything, you don't have any like terms, such as these 2 here. Those 2 here, there's nothing you could do. If they ask you to simplify, it's simplified, you're done. You would just copy it. There's nothing you can combine here, because you've got X and Y and a constant. Here you've got A, B, and C. So that would be the answer. All right, there's nothing you could do. So that happens sometimes. But let's look at number 9. On number 9, I've got variable an M and an N, and then constants. Let's start with M and see if there's any other M to the first. Right here. And that's it. So we only have 2 of them. So I'm going to take 15 and a -8, and that's going to give me a +7M. Okay, so I'm done with the M's. Next, I have N. And usually I go in alphabetical order, but you don't have to, and I'll talk about that here in a second. So here I've got a 9N and a -10N. They both have an N to the first, because the exponents also have to match. So those 2 match. So 9 and a -10 is a -1 when you add those together. So we'll have a -1, and we'll talk about that too. -1N. -10 and a +9 is a -1. We'll come back to this. Those are done. Now we have 21 and 3. Those are constants, and you can add or combine the constants. So 21 and 3 give me 24. So we're just adding those together. So that's an acceptable answer. But I want to talk about this middle term here. Usually we don't put the 1 in front. That is what you generally see instead of this. We don't normally put the 1. My math lab should accept that, because it's not wrong to put that 1 in, but just get used to the fact that they'll just write it as just a subtract N. The other thing is that here the order doesn't matter. So what you could do is you could have the 24 first, and then you could put the 7M. Notice I keep the sign in front, so the 24 is a positive, the 7 is a positive, and the N is a negative. So you could write it like that. So the order doesn't matter as long as you keep those positives and negatives in front of the same thing. Sometimes they'll say go in decreasing power. So let's say x squared plus 3x plus 1, where you go 2, 1, nothing. So then it would matter. My math lab would want it like that. But otherwise, the order should not matter. I just try to go with the variables first, and usually in alphabetical order. So, all right, let's look at number 10. Number 10, wow, we've got these groups. So when you have a group, okay, I've got a term here, and I have a term here. See, each of these groups is a term. Okay, they're separated by plus and subtraction symbols. In order to combine them, the group has to match exactly. So let's look at our first one. We'll just start with this first one. This is an x cubed y. Do you have another x cubed y? That's just an x cubed. There's an x cubed y cubed. That's an x cubed y. We're looking to match the first one, x cubed y cubed. The last term is also an x cubed y cubed. Now remember, because there isn't anything in front, there isn't a number in front, it means that there is a 1. So that's, kind of important to remember. So I have 3 x cubed y cubes, and 1 x cubed y cubes gives me 4 x cubed y cubes. And those are done. Let's look at our next one. Our next term is just an x cubed. Is there anything else, any other term that has just an x cubed? Let's see, we have 2x cubed. That's an x cubed y, so no. There's an x cubed, so that'll work. And that's an x cubed y. So it looks like we'll be taking the 2 and combine it with the -5. And that's how many x cubes we've got. 2 and a -5 is a -3, because 2 of those positives will take 2 of those negatives and leave us with 3 negatives. So -3 x cubes. Okay. When I combine these two terms, 2 and a -5 give me a -3 of the x cubes. Here I've got a minus x cubed y and a 4x cubed y. Now remember, it's not there, so that means -1. So we have a -1 x cubed y, and a 4x cubed y will be 3, +3 x cubed y's. Because you have 4, that -1 will take one of those positive ones and leave you with 3 x cubed y's. All right. So, here, each term was able to combine with one other. But sometimes, you'll have one that you just have to leave separate. Okay. So there's the answer. So that's just kind of a quick little lesson on combining like terms, which is your 2.7. So now let's look at 2.8. 2.8 deals with solving equations. All right, so in order to solve an equation, first off, that looks a little blurry there on the left. Perfect. All right, so if you're here, we have +7. If we want to get the variable by itself, you always do what's called the opposite operation. So if it's plus, you subtract. If it's subtract, you add. If it's multiply, you divide. If it's divide, you multiply. So, when you start to move things, we do what's called the opposite operation. So I want to get that x by itself. That's our goal. That's the puzzle. And to do that, I need to get rid of the +7. Because if you were to draw your line through your equal sign, it's the 7 that's got to go. It's the number that's with the x. So I will subtract 7. I don't know why I drew that line so long. So the x is by itself equals 9, and a -7 is 2, +2, because 2 + 7 is 9. It works. Check it. Let's go to number 8. This is y -11. So in order to get the y by itself, I need to get rid of the -11. So I'm going to add a +11. And because you want to keep the equation balanced, it's like a balance beam. If you do something over on the left, you have to do the same thing over on the right. I'll draw a line here. That's gone. So we have x equals -4 and a positive 11 is going to be a positive 7. So if you were to take 7 and subtract 11, or a positive 7 and a negative 11, you'll get a -4. So it works. Let's do the next one. All right. Looking at this, you probably think, okay, I know the answer because it's, all right, 10 subtract what number? What could I put in for y so I get 3? Well, in this case, it would be a 7 because 10 minus 7 is 3. Well, what if you didn't know that? This one actually requires 2 steps. So we're going to come back to this one because we're going to be doing some 2-step equations to actually go through the process. So let's go to this one. Okay, here with the x, I have a plus -2. So to get rid of that -2, I'm going to add a positive 2. Add a positive 2. So that's gone. Because -2 and 2 is 0. So I've got x equals -9 and 2 is a -7. If you put that back in, -2 plus a -7 is a -9. So if you had 2 negatives and you add 7 negatives, you get 9 negatives. All right. So that's how you get rid of, when you're adding or subtracting. Okay, you just add the opposite in order to get rid of it, but you have to do the same thing on the other side. Now here on 11 and 12, you're not adding, you're multiplying, because when two things are next to each other, like this 9 and this x here, it means multiply. So to get rid of the 9, it's actually what I want to do is make that a 1. So here it cancels and you're left with just 1x equals 72 divided by 9 is 8. Okay, let's check it. 9 times 8 is 72. So here you want it to cancel. Up here, we wanted it to add up to 0. So there's a difference. This one. Oh, also notice up here I was adding the opposite, but here it's not the opposite. Here these will match so that they cancel. You want them to match. Here you're adding the opposite to get a 0. So just sometimes people want to also divide by the opposite. But if you do, then we're introducing a negative and we'll end up with a negative there. So you want these to match. Okay, here, -16. So these cancel. So notice if it's a -16, I divide by a -16, they match. So we come up with x as being equal to 9. Okay, -44 divided by a -16 is a positive 9. Because a negative, 2 negatives, it's even, is a positive. All right, so if a negative over a negative is a positive. In multiplication and division here, when you're simplifying this side, count them, because if it's even, it's positive. If it's odd, it's negative. So many rules to remember. You guys will be fine. Okay. Let's carry on and let's practice some more. 13. The x, you can't have a negative in front either. And remember that if it's a negative, you can rewrite it like this. Those two mean exactly the same thing. Okay, this is the opposite of x, or a -1 times x. It still means the same. So in order to get rid of a negative here in front of the x, I'm going to divide by a -1. Okay, and again, when I'm dividing, I'm matching. All right, it's not the opposite, you're matching. So x equals 17 divided by a negative 1. Well, I know it's going to be negative because I only have 1 and 1 is odd. 17 over 1 is 17. So if I put that back here, negative 1 times a negative 17 is a positive 17. Or the opposite of a negative 17 is a positive 17. If you were to put that back in there. Whoa, okay. Let's look at 14. Again, I want to get rid of the negative 19, and right now it's a negative 19 times C. I didn't draw my line on that last one, but so I'll divide by a negative 19. Uh-oh, I really do not know what 152, so those cancel, by the way. What's 152 divided by 19? Oh, I don't know, 7, I think. Yeah, I think so. But I'm going to double check. I don't want to lead you guys astray. Oh, it's 8. I would have led you astray. So C is equal to a negative. And the reason it's negative is because you've got 1. 152 divided by 19 is 8. I guess that was close. Oh, well. Okay. Now, oh, that is just not good. Hope you guys didn't see that. So here, it's my malware. You take negative 8 times a negative 19 should be a positive 152. Okay, great. All right, so let's do another one. Oh, I guess here we have to pick our approach. So they're not going to tell us. So let's look at 15. It's plus 9. So to get rid of the plus 9, I'm going to add the opposite. Because I want 9 and a negative 9 is 0. Negative 9 and a negative 3 is a negative 12. If you have 9 negatives and you add 3 negatives, you get 12 negatives. And again, a negative 12 plus 9 is a negative 3, so it does check. Let's look at 16. On 16, over here, it's 8 times x. And I know it's on the right-hand side, but that doesn't really matter. It's solved the same. So to get rid of that, I divide by 8. Not a negative 8, 8. I want the signs to match on this process. So I have an x by itself, even though it's on the right-hand side, it's still by itself. 56 divided by 8 is 7. Now you can also write this x, you can swap sides like that. You can just swap them over. It means the same thing. Okay, because 8 times 7 is 56. Let's look at number 17. I have a negative 1 in front. So to get rid of that negative 1, I divide by a negative 1. So it cancels. Remember it now. So here, to get rid of the 8, I divided by 8. To get rid of the negative 1, I divide by a negative 1. But here, when you're adding, then it's the opposite. So we have x equals, because it's by itself, the negatives are gone. 6 divided by a negative 1 is a negative 6, because you've only got one negative, one is odd. I think my finger's getting in the way there. So you end up with a negative 6. If you put a negative 6 in, and the opposite of a negative 6, you have a negative negative 6 is a positive 6. 18. I have a subtract 13. To get rid of that, this is a negative 13. I'll add a positive 13 to both sides. And I can draw my line if that helps some of you. So you have the R, that's gone. 4 and a positive 13, when you add those together, is 17. 17 minus 13 is 4. Okay. Now what we're going to do is we're going to do those two steps together. This is called a two-step equation. You need to be really good at solving these, getting the x by itself, because we'll be using it a lot when we graph lines. So I want you to be good at two-step equations. We always get rid of what's, well, I shouldn't say that we always, because if we have parentheses and numbers, they're going to get more complicated. But for the most part, we get rid of what's being added or subtracted first. So here you do the 7. You get rid of that first by adding the opposite. So -7, +7. I'm going to draw a line there. So we know what we've got, a left side and a right side of our equal. That's gone. So we have 3x is the only thing that's left. We have our equal. 11 and 7 is 18. Then you get rid of the 3 times x by, you don't divide by the opposite, they match. You divide by the number there. X equals 18 divided by 3 is 6. So let's check it. 3 times 6 is 18. Minus 7 is 11. So it does check when you put it back in. Using your PEMDAS, when you put it back in, you multiply and then you subtract. All right. Let's try number 20. These aren't so bad. Here, get rid of what's being added first, subtract 7, do it to the left. You have to go to the right of the equal sign. That's gone. We've got 5x equals 22 and a -7 is 15. Those 7 of those negatives will take 7 of those and leave you with 15 positives. Divide by 5. X equals 3. Does it check? 5 times 3, x is 3, 5 times 3 is 15, plus 7 is 22. So it checks. All right, 2 more and we're done. Okay, here, no, I've got the other one on the other side I want to look at. Okay, so here we have -5, because we want to get rid of what's being added first. You do it to the left of the equal, you have to do it to the right of the equal. That's gone. So we have a -6x. I'm going to move this up a little bit. -6x equals -19, and a -5 is a -24. When you add those together, now you divide by a -6. So they always match in sign in this division here. X equals a negative over a negative. You have 2 negatives, so it's a positive. 2 is even. So 24 divided by 6, you'll have a +4. So again, if you take -6 times 4 is a -24, plus 5 is a -19, so it checks. So there's your answer. All right, here, let's do this one right here. Here's my left side and the right side of the equal sign. So I'm going to get rid of the -3 by adding a +3. You get rid of what's being added or subtracted first. -4x equals 16. 13 and 3 is 16. Divide by a -4. It's always add the opposite, but you divide, you match them. So you get x equals 16 divided by a -4 is a -4. Let's try to check. -4 times a -4, that's what that means, is a +16. -3 is 13, so it checks. It works. Okay, I want to go to that other one here. And I wanted to look at number 9, and then we're done. Here, with this negative in front, we know the answer is 7, because 10 minus 7 is 3. But let's go through the process just so that we have this down. Here, you would get rid of the 10 first. All right, so that would be a -10 by adding the opposite. Okay. So that gives us a negative 1y equals, on the right-hand side of the equal is a negative 7. 10 negatives and 3 positives leave you with 7 negatives. Then you divide by a negative 1. That negative, you have a negative that comes down with it. So y then, negative over a negative is a positive. 2 negatives is a positive, 7. Which we knew it was 7. We knew it was 7. But again, it was just this subtraction comes down, you add the opposite, and then that comes down, you have a negative 1, you divide by a negative 1 to get rid of it. Okay, all right. Okay, that's it for this chapter. So I'm going to go ahead and open everything up, and I hope to hear from you if you have any further questions. Otherwise, see you later. Bye-bye.